I'm cheating.
I'm gonna write it.
All right, so in summary, the normal line is the line that still goes through the point given, but is perpendicular now to the tangent line. So it's going to be perpendicular to the slope at that point. So we'll do the normal line first, then we'll do the tangent line part later. And we want it to be normal to the circle at the given points. So, first of all, we can come up with a visual for this. Where is the circle centered? The origin. And what's the radius? Good enough. Okay. So we actually have 4 lines to write equations for here. The first is at 0, 3. Now 0, 3 is going to help your conceptual. So the tangent at 0, 3, what's the equation of that line? What's the equation of a horizontal line? No, the slope of the horizontal line is 0, but what is the equation of that line? Just y equals 3. So we don't really have to do much work for that first one, because based on our visual, we can kind of take a shortcut and realize the tangent is y equals 3. The normal line at the point 0, 3 is going to be this one. And what's the equation of a vertical line right there? X equals 0. Good, Bryce. So that one we didn't have to do much work. But then at the point 2 root 5, which is going to be somewhere over here. Let me get rid of my initial lines here. So if this is 2 root 5, and we'll do the tangent first, I guess, because that's more familiar to us. We need the slope of the tangent line. Which obviously requires the derivative. So we have 2x plus 2y prime equals 0. And when you solve for y prime, you get negative 2x over 2y, which is negative x over y. So evaluating that slope at the point 2 root 5 is going to give you a y prime equal to negative 2 over root 5. So that's your slope of your tangent line. So when I go to write that equation, point slope form, y minus root 5 equals negative 2 over root 5 times x minus 2. And I'm going to leave that alone. We'll just keep our final answer in point slope there. When it comes time to do our normal at 2 root 5, the only thing that's going to switch, and we've done the majority of the work, is what slope are we now going to use? Radical 5 over 2, because the perpendicular slope concept, opposite reciprocal. So if the tangent line has a slope of negative 2 over root 5, then your normal line has to have the opposite, which means the negative is going to become a positive, reciprocal, which flips the numerator denominator, root 5 over 2. And so our equation for that is going to be the same thing, point slope form, but you're just flip-flopping your slope. And there's your normal line. Okay? Easy enough concept? Any questions? All right. This is not on your note sheet, but I want you to write it down at the bottom. So copy that problem down. Okay, so we're going to try to find any point on this graph, which we have no idea what that graph looks like, at which the graph has a vertical or a horizontal tangent line. Okay, so what do you know about horizontal and vertical lines? What feature, Aaron?
I was going to say, if you find the equation of the circle, you just use that to determine.
I don't think this is going to be a circle.
It looks like one.
It does, but circles only happen, and you guys in Algebra 2 in New York, we don't do as much with conic sections, which are conic shapes, as other Algebra 2 curriculums do. You actually don't do anything with it outside of circles, but circles require the same coefficient on the x and the y. I think, I haven't looked at conic sections in a while, I think that's actually going to be an ellipse, which is like an oblong circle. So if you tried to complete the square to complete the circle, you'd run into a problem that you're not used to seeing just because you've never been exposed to these things. But I think this would be an oblong circle, more like an oval. It's called an ellipse. But going back to my original question, what do you know about vertical and horizontal lines, right?
Horizontal lines are supposed to be 0,
Correct. You know that their slopes are either equal to 0 if it's horizontal or equal to undefined if it's vertical. So if we can set the slope of this equal to 0, that's going to head us towards finding the points at which we have a horizontal tangent line, and then we'll set the slope equal to undefined, quote unquote. That's, we'll kind of figure out what would make it undefined, and that would give us some insight as to where these vertical points are happening. So first, let's find the derivative. So we have 8x plus 2yy prime minus 8 plus 4y prime equals 0. I'm going to add my 8 over and also subtract my 8x over. While I'm at it, I'm going to factor out a y prime on the left. So y prime, oops, I wrote y squared. Y prime will be 2y plus 4 on the left equals 8 minus 8x on the right. And then I'll divide by 2y plus 4. And how can I simplify this? Say it one more time. Divide everything by 2. Good. So 4 minus 4x over y plus 2. Okay. So if we do horizontal first, horizontal lines have m equals 0. So what would make this fraction equal 0? Aaron? Right? So if 4 minus 4x equals 0, and we solve that, we'll get 4 equals 4x, and x equals 1. That's the x-coordinate at which we have a horizontal tangent line. They ask us for the point, so how are we going to find the y-coordinate of the point? Yep, just plug it into the original and solve for y. So if the x-coordinate has to be 1, 4 times 1 squared plus y squared minus 8 times 1 plus 4 times y plus 4 equals 0. That's a quadratic, yes? We have a y squared and a y. So that'll be y squared plus 4y. And then I've got 4 minus 8 is negative 4, plus 4 is 0, so that works out nicely. I can solve this quadratic by factoring. And then I've got two potential y coordinates. Y equals 0 and y equals -4. So the 2 points are 1, 0, but also at 1, -4. Those are the points that have horizontal tangent lines. Remember, I told you this isn't kind of an ellipse of sorts. Would look like that. So it makes sense that you would have two horizontal tangent lines. Yes? And we should also have two vertical tangent lines, I would think, as well. Yes? Any questions? For the vertical tangent lines, we want the slope to be undefined. Would you look at that? We're in the tropics. The sunshine. I know. Might be the last time in a few weeks we see it as well. Right. So now what would make this undefined if you go back to the slope? The y plus 2 equaling 0, which would be a y equals -2. And just like we did with the last one, we got to find the x-coordinate or coordinates that could be paired with that by plugging that into the original. So we go back to the original, 4x squared plus -2 squared minus 8x plus 4 times -2 plus 4 equals 0. And again, this is a quadratic, but we're now just solving for x's. So we've got 4x squared minus 8x. We've got 4 minus 8 plus 4, which is 0 again, so that works out nicely. Factor out of 4x. We get x minus 2. And our x-coordinates are x equals 0 or x equals 2. So the points that I would write would be 0, -2 or 2, -2, where we have vertical tangent lines. So actually, even though you guys don't really know how to graph ellipses, this information gives you some pretty good stuff to come up with a good sketch. Aaron?
Would it be a vertical ellipse?
It might be, yeah. I didn't complete the square and do all the stuff that you would have to do to tell. I was just giving you a rough sketch.
Like the vertical asymptotes.
Yeah, we're going to figure that out right now. So if we have 1, 0 and 1, -4, that's where our horizontal, so that's kind of the top and bottom of our ellipse. And then 0, -2 and 2, -2 are there. And so yeah, so it's stretched more vertically than it is horizontally. Follow? Which there's a totally different way of, there's like an algebra 2 way, kind of consistent with what you used to do for circles, not kind of consistent, very consistent with what you used to do with circles, but I knew immediately that this was not a circle because my coefficients on my x squared and y squared are different. And that just tells you that it's pulled more so in one direction than it is in the other. And it's not, you know, perfectly round. Does that make sense? Any questions? We'll save that for a rainy day. No, I'll show you the other way if I can. I'd have to remember it. I'd have to play around with it. But all right. So that's it for our notes, but I do have your review sheet ready. So your homework for tonight is just the 53 through 57, is that right?
Yep.
Okay. I'm going to also give you the review in advance that you don't have to do anything on tonight, but if you want to, you're welcome to. We'll do more with it tomorrow. And I'm giving it to you because there are a couple questions towards the end of it that are going to tie into what we just did with the horizontal and the vertical tangent lines. And so I want you to get out a separate sheet of paper, because we're going to at least do one at least together. The answers are right at the bottom of this review problem. So there are 16 review questions. Your quiz on Friday is only going to be 9 or 10. And the questions I'm referring to are 14, 15, not even 14. 14 is just the slope of a tangent line, so that's old news. I think 15 and 16, yeah. What are the x values? We're going to do 15. What are the x values of the points on the graph of x squared minus xy plus y squared equals 9, where the tangent to the curve is vertical? So on my separate sheet of paper, I'm number 15. I'm just going to write down the original problem. And I'm looking for the points, I'm looking for only the x-coordinates, where the tangent to this is vertical. So, in order for the tangent to be vertical, the tangent needs to have an undefined slope, so our derivative needs to be undefined. That's really the concept that we're following here. So, our derivative of this needs to be undefined. So, find the derivative, 2x. And then I'll do the minus, and then I'm going to do the product rule here. First times derivative of the second, plus second times derivative of the first, plus 2y, y prime, equals 0. I'll distribute. And I'll move this away and this away. And while I'm doing that, I'm also going to factor out a y prime from the two terms that are going to be left. I don't like to start binomials with a negative, so I'm going to start with the 2y minus the x. And then I will have added the y over and subtracted the 2x over. So my derivative is y minus 2x over 2y minus x. Okay, so in order for this to be a vertical tangent, this needs to be undefined. For something that's a fraction to be undefined, the denominator needs to equal 0. Now this is a little tricky, because I'm not just going to get the answer here. All I know is that my x-coordinate has to be double my y-coordinate. But the point also has to fall on the original curve. So that's going to create a little bit of a system of equations for us. Between this original function, because your point obviously has to satisfy this in order to be on the curve at all, and your point has to satisfy this in order for that tangent line to have a slope of undefined. Do we follow? So if you want a point to satisfy this equation and to satisfy this equation, it's a system. And not a hard system, because x equals 2y. So I'm just going to go back up and sub that into the original. All my x's I'm going to replace with 2y. And then I'm going to solve. So 4y squared minus 4y plus y squared equals 9. It's a quadratic. 5y squared minus 4y minus 9 equals 0. Oh dear. I'm going to say that's not factorable. Uh-oh. People want to argue with me. Emily?
Would you do the 2y times y, wouldn't it be minus 2y squared?
Oh, yeah. Thank you. That's why I have you kids auditing me. All good. So that makes my life a heck of a lot easier, because I didn't want to do a quadratic anyway. 4 minus 2 is 2. 2 plus 1 is 3, so 3y squared equals 9. Divide both sides by 3, y squared equals 3. So y equals plus or minus root 3, which is going to allow me, and the question was, what are the x values of the points? These are the y values. So each y value, positive root 3 and negative root 3, will lead us to an x value. If we go back down here, what's 2 times positive root 3? Just 2 root 3. And what's 2 times negative root 3? Just negative 2 root 3. So the x values at which we have a vertical tangent line are 2 root 3 and negative 2 root 3, which is option D. Good? Can we follow all that?
Yes.
Okay? In number 16, which is a similar thing, determine the value of x where the derivative of this is undefined. Same concept. Look at your answers, though. This is a calculator question. Okay? So when I know you can on your test, so I'll make sure the questions I put on the test are not calculator questions, but know that you can use your calculator for number 16. Okay? And again, your homework for tonight is that page 147, the second half of it, 53 to 57 odd. If you want to get a head start on the review sheet and have questions prepared for tomorrow, otherwise, tomorrow in class, you're kind of working in isolation. And then questions, well, I'll just answer questions as they come up. But if someone already has questions prepared, and you want to not have to come for extra help after school to get your questions answered, if you find a little extra time tonight, get started on that review sheet.